Hi, my name is Favor. I'm here to discuss the EVM. So let's get started. EVM is short for Ethereum Virtual Machine. Now this Ethereum Virtual Machine is a core component of the Ethereum blockchain. Now what does this mean? One of the key functionalities of Ethereum is the ability to execute smart contracts. The EVM is solely responsible for that. So what happens is a developer writes a smart contract in a high-level language like Solidity. And this high-level language smart contract gets compiled into EVM bytecode. Now it gets compiled into EVM bytecode because this is the only language that the EVM actually understands. Once it's compiled into EVM bytecode, it gets deployed on the blockchain and broadcasted on the network. Everybody has access. Every node participating in the network has access. Now these nodes run the bytecode in an attempt to execute the smart contract. One thing I should point out here is the network's ability to run the smart contracts requires computational efforts. And that brings in the concept of gas. Running your contract on the network is not free. So you need to pay a certain fee. Each step in your instruction from your bytecode has a certain charge to it that the EVM would cost you to run it. Now this is just to prevent bad actors from hogging the resources of the Ethereum network, and also to make sure that the resources of the Ethereum network is effectively distributed.
So programs on the EVM are called smart contracts, and they are written in high-level languages like Solidity, Viper, and so forth. So for the EVM to be able to run the smart contract, it has to compile it, and then it is compiled into bytecodes. These bytecodes are made up of opcodes, which also stand for operation codes. So now opcodes are basically represent singular instructions and operations like addition, subtraction, push, and all. So opcodes are the assembly language, and the EVM has its own version of the opcodes, which has standard operations like add, subtract, etc. And then it also has blockchain-specific operations like balance, address, and blockage. So each particular opcode, it has its own associated gas fee, and they play a big role in determining the total gas fee for your smart contract. And they also have different categories, such as we have the logical operations, and nodes. We have the arithmetic opcodes, add, sub, div, the smart contract creation and interaction opcodes. There's the create, delegate, and all. So an understanding of opcodes is really important in optimizing performance of your smart contracts and optimizing your gas prices.
So the EVM is the first level of the Ethereum stack. We have 5 levels. The Ethereum stack is all the technologies that enable developers to build applications right on top of the Ethereum blockchain. Right, so there are 5 levels. There's the Ethereum virtual machine, smart contracts, node software, client APIs, and then decentralized applications. So essentially, a developer has to understand the in and outs of the Ethereum virtual machine in order to produce good code. So the major difference that separated Ethereum from previously built blockchains like Bitcoin is that Ethereum was conceptualized as a global distributed computer. What that means is that anybody that runs a node can run programs, can execute programs on Ethereum, and it's the EVM that enables this to happen, right? So the EVM is also a Turing-complete machine. What this means is that it can run any program. And like my colleague said, the gas is the mechanism that ensures that bad actors can't run malicious or accidental code like infinite loops on the EVM. So once the amount of gas that you pay to run a transaction is exhausted, that transaction is stopped. So the EVM is distributed and is virtual. What that means also is that for every transaction that is sent to a smart contract, with a smart contract to be executed, an instance of the EVM is created like a sandbox in the node, right? And the EVM has different memory locations, so to speak, where it stores different types of variables or data. There's the program code ROM, where, and this part is immutable because smart contracts are generally immutable. They can't be changed once they are deployed. So the code of the smart contract is stored in the program code ROM, that's read-only memory, kind of like a hard drive on EVM, but not really because it's virtual. Then there's also the volatile memory, which contains the stack and the memory location. Here is where the opcodes are run. The opcodes are run on the 1024 depth stack as 256-bit words. So a stack is a data structure where the last data object is executed first, while the memory holds other pieces of information like update logs. And then there's also the persistent memory, which stores the world state, or which stores the state of the Ethereum blockchain. So every successful transaction changes the state of the Ethereum through a transition function. So in essence, once a transaction is executed successfully, it changes the state and then passes that on to the account storage, which also holds other information about the account, like the sender of the account, the value that is passed by the account initiator.
To continue getting more of these weekly updates, I encourage you to like, share, and subscribe to all our social media platforms. Thank you very much.